So without any further ado, we are going to move on to the next session, which is on the theme of smart vehicle technologies and alternate fuels. Kindly bear with us while we make the necessary table arrangements. I'd like to now invite our session chair, Mr. YB Ramakrishna, who is the chairman of the working group on biofuels from the Ministry of Petroleum and Natural Gas. May I now invite him to join us on the dais. May I also invite our experts for the session, Mr. Jeffrey Hyout, Senior Program Manager from APTA, Mr. Nishant Arya, who is the Executive Director of the JBM Group, Mr. Madhav Pai from the WRI Ross Center for Sustainable Cities, Mr. Magnus Broback, City Mobility Director, Volvo Bus Corporation, Mr. Urban Lofvenberg, Project Manager, Sustainable Solutions Buses and Trucks from Scania, and Ms. Anumita Roy Chaudhary, who is the Executive Director for the Center of Science and Environment. A very warm welcome. Our session chair, Mr. YB Ramakrishnan, has served in the corporate sector for over 3.5 decades in various capacities, both in India as well as abroad. He started the C-Cube Electronics and has served as its president and CEO for over 2 decades. He is a founder-president of Samagra Vikas, a not-for-profit organization working on environment protection, alternate fuels, renewable energy and rural development. His work has focused on bioenergy for over 2 decades and served as chairman of the Karnataka State Task Force on Biofuels set up in 2008. His work on biofuels has earned global recognition, and ICRF, a UN organization, has adopted the biofuel model evolved by him for replication in other developing countries. He's also served in several committees on agriculture, forest, environment and energy, set up both by the Government of India and Government of Karnataka. Ladies and gentlemen, may I now request our session chair to kindly make his opening remarks and chair this session. Meanwhile, may I request members in the audience to kindly take their respective seats and settle down. Thank you.
Excuse me. You will be introducing the speakers, or I will be doing it? Okay. Good afternoon to all of you. Sorry, we are running out of time, and you're not getting the break that you are supposed to have got now. Anyway, the present session is on the smart vehicle technologies and alternate fuels. We have quite distinguished speakers here who have been going to be talking on the various initiatives from their own organizations, and also with regard to the issues that we have as far as the various types of alternate fuels are concerned. Ever since we started using motorized vehicles, we have come a long way, and we have seen that we have moved from one type of fuel to other type of fuel. I still remember in my childhood having traveled in a bus which was fueled by charcoal, and you still get to see this. It was there in front of the Bangalore bus station for a long time. I don't know if it is still there, so they had just displayed it. And then we have been talking about various different types of crude-based fuels. You have gasoline, you have diesel vehicles. Now we have been talking about the hybrid vehicles. We have been talking about vehicles based on CNG, and we have been talking a lot about the biofuels. We are talking about substituting the petroleum fuels with the kind of fuels that comes from the bioresources like ethanol and biodiesel, and we are also looking at fuels like methanol in future. And every time we talk about a new fuel, the kind of vehicles that have to run on this kind of fuels also go through a whole lot of changes, and then from one fuel to another fuel you have issues with regard to the pollution. So there are several such issues that need to be addressed as we move over from one fuel to another fuel. But today we are in a situation where you have different technologies when it comes to the vehicles, and you have different mix of fuels that are being used, and we are also looking at a whole lot of new technologies and new fuels. So for example, we are talking about hydrogen fuel cells. You have a few vehicles here and there running on hydrogen fuel cells, but then again, hydrogen being so expensive to produce, we're also thinking in terms of methanol and ethanol based fuel cells, which could probably be driving the the transport sector in future. So there are several issues, and we have quite a few distinguished speakers here, and I'm sure they will be able to throw some light on all this. And being a biofuels man, I would probably take a few minutes at the end talking about some of the initiatives that have been taken in this country. So we have our first speaker, Mr. Jeffrey here, is the Senior Program Manager with American Public Transport Association, which has about 1,500 members, and he's been with APTA for over 8 years and manages the APTA's bus technical services and standard development program in the development of transit industry standards. So he's also the staff advisor to the Bus Technical Maintenance Committee, Clean Propulsion Committee, Bus Operations Committee, and Systems Engineering Subcommittee. Over to you, sir.
Thank you, Mr. Chair. All right. Good afternoon. Thank you for sticking around for this the last session. I'll try to speed mine up and do it in about 10 minutes. I think we were asked to truncate our presentation. So I'll go ahead and get going, and hopefully we can get through and get the day done. So I'm going to talk a little bit about the growth of alternative propulsion technologies in the United States, and some of the challenges in implementing these new technologies in buses, some of the risks associated with implementing these technologies, and then how we're trying to standardize the process to make it a little bit easier and mitigating some of these risks and making it easier for transit agencies to procure alternative propulsion vehicles. So when we talk about alternative propulsion technologies, in general, we're talking about clean diesel technology, natural gas, which would be like the CNG, hybrid electric, battery electric, and hydrogen fuel cell. And most of my discussion is going to be on the last two, on battery electric and hydrogen fuel cell production, is kind of where we're focusing on in the U.S. with what we're calling zero-emission buses. So you can see on this chart, it's kind of the projected growth as a percent of the total U.S. bus fleet. You see back in 2000, it was a very small percentage. CNG has really rapidly grown in the U.S. the past several years, where most of the buses that are being manufactured our CNG buses right now, but there are some other alternatives with electric, hybrid electric, that are also gaining market share in the U.S. And over the years, the United States federal government has provided a lot of programs that have facilitated the growth of these zero-emission bus technologies. And as they move into the commercial market, there have been some ways that our Federal Transit Administration can expand its role in promoting these new technologies, in addition to their capital support for deployments. So I'm not sure if you're aware how the buses are bought in the United States, but the federal government funds 80% of the bus purchase, and the transit agency is responsible for 20% of that cost. So the federal government takes a big role. They're taking a lot of risk in these vehicles. So it's in their favor to really implement some of these programs to really test out these new technologies. And we all know that this technology is moving at a very rapid pace, and there's a lot of new. Each year there's coming out with a new generation, and so the performance is improving. And because it's new, when operators are engaged and they're committed to this, that the commitment has to be there, where there's that commitment to taking on this new technology, so then that the manufacturers are able to get their latest versions out on the street and be able to focus on providing their energy and supporting and bettering their technology. So the progression typically is to have, when you kind of look at the risk of procuring these new technologies in any kind of vehicle, in the U.S., the government starts out sharing a lot of the liability and the ownership, and there's an ideal progression of, where as it becomes more commercialized, the risk is being shifted to the manufacturers and the transit agencies. And recently, with these new technologies of electric vehicles and hydrogen fuel cell and other zero-emission buses, the risk is still is mostly on the OEM side. And so we're trying to get that progression more idealized. So the evolution of some of the risks that involved, right now in the United States, we have what we call Buy America, and it's BUY America. And so that kind of puts us in a little bit of disadvantage with some of the ways that we can buy vehicles, because most of the components in a bus, or anything for that matter, but in this instance in a bus, has to be built in the United States. It has to be assembled in the United States. So that's reduced some of the manufacturers that we have out there, and also some of the component manufacturers. So there's a lot of perception with risk, and in CNG specifically, there's a perception that there's no risk, and even in diesel. But we only have one engine manufacturer that can sell engines in the U.S. So there is some risk there. And example with hydrogen risk, there's a perception of unacceptable risk because it's an emerging market, and it just is seen as a larger risk in the industry. There are also a lot of challenges in implementing these new propulsion technologies. From a broad perspective, the barriers to zero-emission bus procurement are not that different from challenges faced on commercialization of any innovative technology, especially those whose primary benefits stem from being environmentally and socially responsible. However, you can see this list on this slide, there are some challenges, and infrastructure is a large challenge to implementing these two technologies. There's a lot involved in the charging systems, how they're being charged, overhead charging, if there's conductive charging, and a lot of these extra areas that have to be considered when procuring these new types of technologies. The batteries is still a big issue, and getting affordable batteries, and how to, even when a battery's life is over, how to dispose of the batteries. So there's some challenges dealing with that. Just the fast charging, or what is the range of these new vehicles, and how can they be charged to be able to be put into the service that's needed for the transit agencies to operate these buses. And also just lower production costs. the electric battery bus has gone down significantly in the past years, where it's actually getting a little closer to some of these incumbent technologies like CNG and diesel buses. There's still a difference, but it's getting closer. Hydrogen fuel cell still has a ways to go. It's still not on that commercially viable end of the spectrum, but it's getting there. Some of the other challenges is that, we're looking at this list here, and thank you. Oh, I'm already running too long. But some of the challenges that are listed, just in procurement, we're doing work within the United States to kind of bridge the gap between federal funding partners and how we can mitigate some of these risks, and providing a less complex roadmap for agencies to move to this cleaner vehicle type. And a lot of that is by figuring out ways of standardizing so we can the process for procuring these vehicles and making better information available to the transit agencies. And that kind of leads us to the next one, of partnerships. And I can't stress how important it is for all partners in an emerging technology to understand the risk and the pressure for everyone involved. So in the United States, there are 3 different entities that are taking on the risk: the federal government with their money, the transit agency for buying the bus, and the manufacturers. And up until now, the manufacturers have taken on most of the risk. So communication is really big to managing these expectations and having strong leadership within the organization. And lastly, a challenge is really showing the commitment, because as I stated, when talking about risk, minimizing for only one creates more for another. So all parties involved in the launch of these emerging technologies must understand the commitment, and they must have the leadership to support their team while ensuring that the operations department, they don't get stuck with trying to figure out how to deal with these new technologies and then park the buses and not use them and not put them in service. So what are the risks versus reward? Well, there are benefits. Obviously, environmental benefits is the biggest one, but there's some differences too. These vehicles are very complex. The configuration, the integration of parts, that means that there's a big need for training. We have an aging workforce in the United States, and the mechanics are used to working on simple buses, and now we have these technologies that are requiring complex systems that are requiring a lot more training. Additionally, just the replacement of the component parts and their availability are challenges that have to be overcome. So there are some questions that we ask that and that you have to kind of ask the agency and all the stakeholders involved to the commitment and how they can support and make sure that everyone is in support of these new technologies. There are some spillover effects to these new technologies that we've been able to realize, and some positives and some negatives. And the positives are noted at the top. They're not only important to transit, but they've also important to heavy and light-duty vehicles as well. And a lot of these have been tested and been actually trying to transition some of these technology into the personal vehicle route as well. And the last 3 bullets are some of the negative ones. It's constantly evolving, as I mentioned. The economy is tough, and just the lack of commitment, and that we still need that commitment. And I'm going to quickly go through these last couple of slides because I think I've kind of hit my time limit. But one of the things that we've done is develop a standard bus procurement guidelines, which is a single guideline. And really that's kind of, the point is to standardize a lot of the components, a lot of the language that's used in procuring these vehicles. And so it's making it very consistent so that when transit agencies are putting together their requests for proposals, that the manufacturers know what to expect, they're able to reply, they're able to give a proposal that's based on performance and not on design. So having this information allows for the transit agencies to really just be able to tell, this is how we need this bus to perform. Now you design the bus that will meet our expectations and meet our service needs. So they're just designed to allow a lot of flexibility, but yet make the whole process a lot easier. So quickly to concluding remarks, now is the time for the transit industry to be on the forefront of the environmental protection movement and looking at our climate change. There's a lot of evidence out there that supports this, and the transit agencies around the United States, they are employing a lot of new practices in this effort. And zero-emission buses are on the cusp of commercialization if they're not yet there right now. Market development for this technology can be accelerated. It just needs the proper leadership and the industry support and the support of all the stakeholders involved in implementing and testing and running these new technologies. So it's very quick. Hopefully it's a little bit helpful, and I'll be around if you have any questions later on after today if we don't get to them at the end of the session. Thank you very much.
Thank you very much. There have been some requests to change the order of presentations. We have a couple of speakers who may want to leave a little early. We have Mr. Sri Madhav Pai, who is going to be presenting next. He's from the WRI Ross Center for Sustainable Cities, and he's the India Director, based in Mumbai, and provides overall leadership and management to this program. He has about 15 years of experience leading, designing and managing urban transport programs and projects in India, Asia and United States. So over to you, Madhav.
Thank you. So I'm going to share some research that we did, which was actually basically a meta-analysis of exhaust emissions for urban transit buses. I think a lot has been said about this since the morning, so I'm not going to go, but basically, really three sort of categories of emittents and sort of impacts, one on greenhouse gases, one on air pollution, and then sort of the health impacts that come mainly from PM, etc. And then, these are sort of the vehicle propulsion technologies that are available. Basically what we did, and we actually, this research, and my colleague Umang Jain is here, this received an award at the annual TRB conference last year. It basically brought together sort of data about exhaust emissions from a number of cities. And just these are some slides about why sort of meta-analysis, how it works, and it's basically not individual sort of testing, but it's actually assembling a lot of results from a lot of different studies and places. But that allows us to give some numbers with a sufficient confidence interval. So basically, a lot of these tests have been done in international locations, some in Mexico City, and there are a lot of averages. But essentially, basically, what the results showed is, these are basically what the results showed is there is no silver bullet. CNG has its problems, diesel has its problems, and what you essentially need is post-processors help a lot, and hybrid and hybrid electric is definitely better than CNG and diesel, but then there is the cost element. But you can achieve a lot for cleaning up both CNG and diesel, and diesel with lower parts per million if you do the post-processors. So, and what you see is the DPF, the D50, the SCR, these are all sort of technologies of post-processors that have been used. So these are the sort of NOx results. These are the PM results. So if you see, D50, that is sort of, 50 parts per million diesel, and all the diesel numbers are in yellow. So the 50 parts per million diesel, PM 2.5 is very high, but once you put a post-processor, so either like DPF filters or you make it hybrid, then you are substantially able to reduce the PM 2.5 emissions from diesel buses. Similarly for CNG, you can see CNG plus oxidation catalyst really works, right? And then, then CNG plus 3WC, three-way catalyst actually is quite good. And so, so what it does, it's actually also looking at biodiesel with SCR and ECR and all this. So the point is, post-processing is extremely important, which actually none of us sort of do. And I had some number. Basically, the thing is that CNG plus 3WC actually works best. Sort of, NOx is very bad. You can see how bad NOx is for CNG. So the purple is basically NOx emissions from CNG. So CNG is pretty bad on NOx. So, but once you use a three-way catalyst, then CNG with three-way catalyst actually does very well, both on NOx and then on PM 2.5. So the point is, a three-way catalyst actually is a good thing to use, or using a low sulfur, which is 50 parts per million with DPF also is excellent. So this is simply the problem, and I'll show you with some work we did with Bangalore also, that the additives market and the post-processor market is very bad. It's mostly monopoly suppliers and the costs are very high. So I just wanted to show you, so there is a sort of general findings is that technology and diesel quality are extremely important, and and that you need to sort of analyze everything in the local context with these 3 parameters in mind. And again, so these are sort of the various post-processor technologies that are available, and I think we really need to find a way to make sure that sort of after treatment technologies are a part of the process. So just again sort of giving you examples of parts per million. Now Europe and all have gone to 10 to 15 parts per million of diesel. I mean, this is really, the ultra low sulfur diesel is extremely clean, and then once you use it with DPF filters, I think you get much better results. The thing is, the other thing that I've also personally noticed, personal experience, CNG engine technology, for example, in India has really not evolved. We are using 20-year-old CNG retrofits with clean sort of fuel. Year 4, year 5 performance, and this is what I've personally also seen in Indore where we've worked closely. Year 4, year 5 CNG vehicles perform really poorly. Maintenance costs are sky high, and the operators, it's a big impact on the business of the operators. So that's where diesel sort of, they are actually happier to use diesel, and if it's because it's easier on maintenance as the vehicle gets older. So I think I think one of the other things is we need to look at life cycle as well, and not just look at sort of the point of time when it's purchased. And of course, India is also now, the major cities have all moved to 50 parts per million, and now with these NGT orders, etc., we'll move more and more to cleaner diesel. So I think if you want to persist with CNG, there has to be a big push on actually having better CNG engines, because right now we're using really low quality CNG engines and CNG retrofits. Here's just some numbers from the Indian context, again NOx versus PM, and you can see how currently the diesel is sort of in the worst quadrant to the right, which is diesel that's greater than 150 parts per million. But once we get to diesel with 50 parts per million and using the particulate filters and the CNG with oxidation catalysts, we're all sort of moving to the left quadrant. We're still not best, but I think these are sort of clearly options that we have. So I think the main conclusion from this analysis is that we need post-processor treatment. Yeah, and just couple other things I wanted to quickly show, since these are sort of the these are sort of about electric. A point to make is I know electric buses and these are there, but the big problem is our power, our energy is very dirty. If you're going to use dirty coal to run electric buses, that's not going to solve any of your problems, right? So I think what now, this is something now they've been doing in Japan, etc., where they're connecting to smart grids. You need to essentially connect your electric buses to your smart grids. Otherwise, you're just sort of, it might still have positive impact on exposure to criteria pollutants, exposure to PM 2.5 in cities. So, you have health benefits, and you are starting to see results from New York, etc., where the asthma rates, etc., have gone down once they've moved to electric, especially around the major arterials. But the point being, if you're using dirty coal to make your electricity, then it's like you're just moving the problem from the cities to somewhere else. And then on biofuels, and I think this is also research, I know there was a lot of talk about biofuels. This is actually research that we've done as WRI, which is mostly from a food perspective. So this research was done mainly to talk about a sustainable food future, and food security is a big problem, and based on a very extensive study done in Brazil, it's extremely clear that we cannot use land that we need to grow food to grow fuel. It's very clear. It might be sort of, so that's an extremely important point. And so from that perspective, I think biofuels really, it's okay if we're using sort of waste to biofuels, but to grow crop for biofuels or for ethanol is really not going to work from a food security perspective. And food security is going to be a big problem very soon. Water security and food security. So from that perspective, I think, biofuel also has to be carefully thought. Again, it's nice to be 10%, etc., things that are coming from waste and waste to energy type of stuff. But to grow biofuels, to grow fuels for crop, there's a huge issue, and I think that needs to be thought through fully. So mainly, and then I just again wanted to make the cost perspective, just these are some numbers. They're a little old, they're in euros, but to give you a sense of what the costs are. And so in Indian context, costs are extremely important. And these are just capital costs. I think an even bigger point is operating cost. I'll give you an example from Bangalore, and that will be my last point. BMTC, is moving to BS4 and now BS5. Which is a big, again, an order from the NGT. Everybody has to go to BS4 and BS5 by 2017. Fuel efficiency dropped significantly when they moved from BS3 to BS4. And the cost of that fuel inefficiency, if you want to call, was about ₹500,000, right? Where does today BMT, the thing is, one is capital cost, the other is operations cost, right? And BMT, this is where, BMTC anyway, was, just sort of all the talk of profit making has gone in the last couple of years, and this additional cost from the fuel efficiency became very difficult to justify. So, when we're talking about moving to some very higher cost technologies, I think, we do also need to talk about how we will, make sure the subsidies and the operational subsidies are in place. Otherwise, we're not going to be, we're going to have problems on maintenance, etc., and deterioration will be much quicker. But you can see this, what you see in red is the drop in fuel efficiency as you move from BS4 to BS5. And the reason for that is typically BS5, engines are, BS5 vehicles are heavier. I mean, you're going to almost a 11 ton vehicle. You're going to a higher engine, which is a 210 horsepower. So that's requiring more fuel. So I think, but the thing is, when the MTC was given these buses, they said, here the capital cost is borne, but they didn't know they had to deal with such a high operational cost. So, I think these operational issues have to be addressed, and, you need to think of it in life cycle and not just in capital. And I think that becomes an extremely important consideration while you're making these choices. Of course, the other problem is what we thought, there is a way to reduce this cost, okay, that you actually don't probably need a 210 horsepower engine to run a public transport bus. But the thing is, Cummins today is catering to the truck market, and it's making only 165 bhp engines and 210 bhp engines. It's not making a 180 or 185 bhp engine, which would be the ideal one. But who's going to pay for that higher, that's where the high fuel efficiency comes. So, these are sort of very practical considerations that one has to also think about, and I'm sure a lot of the SRTU people will agree. And, how do you then sort of bear these additional costs on operations? And, how do you sort of ask for subsidies, etc. for this in an already sort of cash-strapped institution becomes a challenge. So, these are sort of the main points I wanted to make, and end with on a positive note. Again, so Bogota, which is not, is a developing country city, has the largest sort of hybrid electric buses, 200 buses. So, it's possible, some of them mostly run in the BRT corridor. It's possible to do it, but all I'm saying is, first, I think post-processors is extremely important. So we need to find how we can create a market for post-processors in India. Today there is a single additive supplier who just there's a single additive supplier who charges exorbitant rates. So one is one sort of pushing for post-processors and making sure that there is a market or there are multiple suppliers that can do it. Second, really think about life cycle costs and the impact on the sort of operations on the operators and how we're going to arrange for subsidies, etc. to cover it. And the third is that there are some sort of good progresses that are being made in the electric hybrid space, and that we need to figure out how we can figure out financial models to then start to make them part of our fleet. So with that, I'll stop. Thank you.
Thank you very much, Madhavbhai. And we have our next speaker, Srimati Anumita Rai Chaudhary. She's the Executive Director, Research and Advocacy at the Center for Science and Environment based in New Delhi. She's in charge of the Sustainable Cities program that includes the sub-programs on clean air, sustainable mobility and green buildings, and sustainable habitat. So over to you.
Thank you so much. Well, it's actually going to be exciting now to speak on CNG after Madhav. I'm looking forward to this for a very simple reason that in this mobility transition that we are looking forward, we know that the buses are going to play a very critical role. And today in this session, what we are really focusing on in this whole frame of change is the technology of buses. And we also know from the panel, and this panel, the part of industry this panel represents, is coming up with a very wide portfolio of what we call the alternative engine technology and fuels. And what we really want to know is the potential of how we can leverage this innovation in this sector. Now, when that is the question, then understanding the CNG experience in India is very critical, because CNG is truly the first experiment with alternative technology at some scale. Now, so if we have to draw some lessons from this, and very strangely in India this has actually degenerated to a debate as a CNG versus diesel debate. And CNG has now been around since 2000, and so many years, and since then the focus of this debate has been that even diesel can be as clean as CNG, provided it's clean diesel, provided there is a trap. Now 15 years have gone by, we have seen CNG evolving, but we have not seen clean diesel yet in this country. So clearly, therefore, we really need to understand the nature of this transition and the focus of the debate. The reason, now let's first understand the first generation CNG program and the imperatives of that program. Why did that come about? And clearly at that point of time, the decision which first came from the Supreme Court in 1998, sulfur content in diesel then was 2,500 ppm, and we were at Euro 0 level. And when CNG order came, along with CNG, the CNG actually became a catalyst to push even the emission standards for diesel buses, which became Euro 2. Now, the reason for bringing CNG at that level was that very high level of pollution in cities and very strong concern over diesel toxicity and very poor quality of diesel. In addition to that, the fact was that emission standards at that point of time was certainly not fuel neutral, because every time the industry has been saying, please give us the standard and let any fuel meet that standard, that principle simply did not work for the simple reason that there was an enormous gap between CNG and diesel emissions. It really required a mandate because alternative fuel market cannot take off without a legal mandate. CNG also it made a lot of sense to us at that point of time, given huge concerns over fuel adulteration. And when this particular order came, which linked clean fuel with public transport augmentation, for us, it was a win-win in the year 2000. So this was the data on the base which actually justified the move, and which also showed that why CNG at that point of time was a way to leapfrog our emissions. So what you're here seeing, actually the study carried out, the test carried out by ARA along with Terry, it shows that how the Euro 2 diesel bus at that point of time in India was emitting 46 times higher particulates compared to the comparable CNG bus. It also made, because now everything gets tested within the framework of co-benefit, it also made climate sense. So if you look at the data from the same tests, look at the CO2, look at all the parameters, it justifies the move towards CNG. There were concerns that whether methane is going to be an issue from CNG, because again, if you want to take climate as a benchmark to test its success. So this very interesting study that came up that said that with CNG, methane emissions might have gone up. But if you consider that the CNG fleet has replaced old diesel fleet, and you take into account black carbon, which the potential of the warming potential of that is enormous, then at the end of the day, the net result you get that the CNG program in Delhi could actually reduce the warming potential by at least 30%. So clearly, that was the basis on which we established this program. There were glitches and there are lessons, because each and any new technology, any new fuel will require its own ecosystem, its own standards, its own maintenance regime, its own fueling systems, and there were many glitches that we had to face at that point of time, but a lot of things were also overcome. And those lessons are there for all to see. And finally, what we got out of that first generation is also the primary driver of this program was air quality and health. So all these studies and also the estimates available from the official State Pollution Control Board, the Central Pollution Control Board, it's very clear that we also got the air quality gains. Now, the questions are that was the first generation. Now today we are facing the second generation challenge. We know today that we have arrived at a stage when buses are Euro 4 compliant in many cities. We know that today the CNG program has a potential to expand to several other cities. In fact, very large number of cities. Already 60 cities in this country have access to natural gas. Now from that perspective, how do we look forward? And how are we now going to make our choices? The first choice was made when we were at Euro 0 level. Now today we are at Euro 4 level, and we are looking forward, and we expect both CNG and diesel to improve. So how are we going to make choices today? So all the time, even during the time, we had to face a lot of disinformation over CNG. There was a lot of lobby pressure that why CNG is not going to work, why there is so many problems with CNG, and it was always about finding fault with CNG, even though today all data shows that we have got enormous air quality and public health gain from that program. So just a few days ago, again when the media again became quite abuzz with one statement from CSIR based on one of the very recent studies claiming that CNG emits more nanoparticles than diesel. And therefore, and again the red flag was up, the entire media, it again hit the same controversy. So when we delved and we investigated, we tried to find more about this study, we were actually pleasantly surprised. And when we got the data from CSIR, we found, and we were very surprised about the fact that why the right messages have not been given out from that study. Because when we looked at the actual data, and it's good to see this data, because this is, I think, the first study done on Euro 4 CNG bus and Euro 4 diesel bus in India. And this is the real-time emission testing. And this shows that today, if you compare ultrafines between our own Indian diesel and CNG, then the diesel is emitting 600 to 2,000 times more ultrafines. If you compare all other, and in fact we have not done this comparison, it is a CSIR study. The data actually shows that the CNG buses are already pretty close to the levels that we have for Euro 4. Where they have made that observation about ultrafine more than diesel from CNG is when they have compared this with the advanced Canadian bus today meeting the 2010 heavy-duty emission standards of the US, fitted with particulate traps and SCR. To that they found that our CNG, conventional CNG bus emits 12 to 40 times higher ultrafines from that Canadian bus, but our Euro 4 diesel bus emits 28,000 times higher ultrafine than that Canadian bus. So from that perspective, let us be very clear that the data from them is very powerful. And therefore, when we looked around the world and we looked at the VTT study for the NOx, for PM, for NOx, for ultrafines, and when we're looking at where all the buses, the current models are, it is pretty clear that there's an enormous potential of that technology to deliver on emissions and environment. And this is fascinating to see that if you look at what level diesel buses begin to become comparable with the CNG buses. And not going to read this out, but it's pretty clear out there. Now the point is that how this technology roadmap is evolving in this country, and we expect, and today the matter of concern is that we still do not know when the Euro 6 emission standards are going to be in place, because Government of India has not announced the emission standards roadmap yet. Now from that perspective, we do not know when the clean diesel is coming with the trap. So if we go by what is being said, that if Euro 6 is coming in 2023 or 24 or Euro 5 in 2021, which means for another 5 to 6 years, India will not have clean diesel. And which means that here, if that technology is not going to evolve to address the issue, then that actually creates more opportunity for CNG. And CNG technology has already evolved. But if you look at the CNG trajectory, and I will differ from Madhav on that, how we have moved from the simple conventional carburetor to now first to the lean burn, and then the post 2010, we have already moved to the more improved stoichiometric with three-way catalytic converters. So which means that by looking at the data also, that the technology that exists today with us has a much better potential to meet the tighter standards more easily. And therefore, when we look at this, and this is the question that we did, it's just an example from one company, that when a bus operator has to decide now, and if they have the option of accessing CNG, then you have to look at the complexity of the technology to meet the same performance, emission performance. So when you look at the top one, which is the CNG, where you know that just by improving your lambda control and your three-way catalyst and engine management, that is the way CNG is going to move ahead to meet Euro 6. Whereas when you look at the complexity of the diesel after treatment, starting from the oxycat to your particulate filter to AdBlue injector to the AdBlue mixer to SCR and the final, and understand what this complexity means. And therefore, it's not going to be easy both in terms of maintenance. So much has been said about maintenance of CNG because we do not have diesel buses today with complex after-treatment systems. But when we begin to get that technology, and given the maintenance regime that we have in the state, the bus transport undertakings, then it is going to be an enormous challenge. Similarly, so finally, what I really would like to say, that the message is pretty clear. Cities that do not have CNG, they will certainly have to leapfrog to Euro 6, because only at Euro 6 level you begin to get effective reduction in both particulate matter and nitrogen oxide. But if you do that and you know what the technology is, it's absolutely essential that we have very stringent in-use compliance strategy. We know there are challenges with low load, low speed urban driving condition when for some time your after-treatment devices are not perhaps going to work effectively, and you will have uncontrolled emissions. And at the same time, other complexity with urea refilling, etc. will be a challenge. And those who have access to CNG, it makes immense sense for them to move on to the CNG path. And there are a whole lot of other alternative fuel options that are emerging today that the cities should be looking at. But of course, we know that for the CNG cities, you would really require also maintenance regime. But we need to keep in mind that this is going to be much simpler than managing the diesel technology in the future. So efficiency is also an issue that we have just heard about. But if you look at the way the technology is evolving today, we are seeing dramatic narrowing down of the efficiency level between CNG and diesel. So clearly, in fact, the very recent demonstration by Scania, we found that it was nearly 5% difference between their model and the diesel model. So the final slide for me here is that bus technology is evolving dramatically, and we will have to benchmark that. And it's absolutely essential that we need to understand the cost and the technical complexity of both diesel and CNG. CNG certainly shows a much simpler way of moving forward. But this does not mean that we are saying it's CNG versus diesel. We want a fuel-neutral approach, and we know fuel-neutral approach happens only at Euro 6 level. And therefore, instead of fighting this as a CNG versus diesel, please demand quick leapfrog to Euro 6, and that's where the community has to become unanimous in making that demand. And with that, for all alternative technologies that we are going to be discussing today, just not CNG, be clear, we need a legal mandate, we need fiscal and regulatory measures for market development, we need favorable taxation policy to make them compete with cheaper and dirtier mainstream technologies. And that has to be the focus of moving forward. So clearly, this is not CNG versus diesel debate. This is about toxic versus cleaner emissions pathways. It is about poor performance versus efficient performance. This debate is about our health. Thank you very much.
Thank you. Before we move on to the next speaker, the last two speakers would like to leave a little early. Maybe I think, we'll, if there are any quick questions to Mr. Madhav Pai and Anumita Roy before they leave, the questions are welcome. Well, if you don't have any questions, I think we'll move on to the next speaker. This next speaker would be, as listed, it is Mr. S.K. Arya. I think he's being replaced by Mr. Nishant Arya. Nishant Arya is the Executive Director of the JBM group of companies, headquarters in Delhi, NCR. They have a very diversified portfolio to serve in the field of automotive, engineering, and design services and renewable energy sector. They have over 35 manufacturing plants, 4 engineering and design centers across 18 locations globally. So, Mr. Nishant Arya.
Go start my presentation. Nishant Arya. Yeah. Good evening, ladies and gentlemen, people from the government, friends from media. Today I would just like to share my perspective with you regarding the role of technology in alternate fuels. Today, all of us in the last 20 years have really seen that how technology has moved from being a luxury to being a necessity. It is a part and parcel of our life. We can't function without it. And how different technologies are being used by each one of us, we don't tend to realize this over a period of time. And now in the future, how technology will play an even bigger role in different ways and means is for us to really understand. And similar transformation is going to happen in the transportation industry as well, where all of us are really seeing which trends would really cater to the customer requirements, whether it's the components of smart mobility, like if I talk about the wireless communication systems, the computational technologies, or the floating car, the video vehicle detection, induction loop detection, and sensing technologies, which are becoming a must for us in today's environment, because all of us really need that kind of comfort when we're using any kind of vehicle or any public transport. In today's date, I think communication, whether between technology systems, between vehicles, is a must, because effective communication is very essential for us to move forward. So in these times to come, I think this will be inevitable for us to really proceed. Today we see that the environment is really going from bad to worse, because the oil usage left is only for half a decade. 56% of the world's oil consumption is from transportation, and 95% of the world's transportation is powered by fossil fuels. So we are really consuming what we have in a short supply. So therefore, we need to use it well, and we really need to see how we can preserve it for the essential commodities and the upcoming generations. But what can we do is what we are looking forward from why alternate fuels. Because alternate fuels today for us are environment friendly, they are clean and sustainable, and they look forward to supporting us for preserving the conventional fuels, and we have the requisite technologies today available with us which can really cater to our requirements and applications in different industries. Recently, just about a year back, this was a study which was done across 40 different countries where they saw all different kinds of fuels which are being used. So different countries, depending on the applications, different cities, their demographic and geographic requirements have given this data, where people feel that whether it's natural gas or it's hydrogen or hybrid or electric vehicles or biodiesel would be the real solutions in the future. Because today when we see key cities across the world, Delhi is considered the most polluted city, where the PM is 153, and just now few people were talking about it being less than 15 times to come, which is something we are looking to move towards. But is that really going to happen without taking certain steps? That is very essential for us to really make these moves, whether by SRTUs, whether by governments, or we as a public. Because alternate technologies are a key. But today we have, as we see, many possible approaches, but how many of them are viable? Because any particular customer or end consumer is looking forward to something very sustainable, scalable, and affordable, with the right level of safety and comfort. So how are we able to give that kind of safety and comfort at an affordable level to people in India? Because the challenges which we have in India across different cities really have to give a unique solution, we have to give a unique solution to it. So therefore we have to see which technology can be adapted by us in this case. Today current trends are that in different countries, hybrid and electric vehicles, fuel cell, ethanol and biodiesel based vehicles. Even today we see there are few vehicles here, as the Honorable Minister also shared his vision in the morning, how the government is moving towards that, and he's bent upon to make it happen. But how we as an industry, whether as manufacturers, whether as end consumers, as a layman, or as SRTUs are gunning towards it, that is the key. If I talk about the fuel cell buses, definitely they have their own benefits, where elimination of tailpipe emissions, improved fuel economy, lead to green cities, and there is a greenhouse gas emission reduction as well. But is it affordable today? Is the kind of infrastructure which needs to be put in place is there? How are we able to do it? These questions arise. Then we talk about green mobility, mainly coming from the electric and the hybrid buses. How the zero emission operations or the diesel auxiliary power unit or the extending system with the diesel engine is there in the battery bus. But as we heard before, are all these things coming with the right source of generation of energy, even if it's an electric vehicle? That is very important, that how we are really seeing the right source of energy for generation, whether it's coming from any renewable resource, whether it's solar, wind, or so-called so forth. Only then we are actually giving forward a green vehicle with the right technology, because ultimately the environment as well as the health is a very important factor for the public. The complete supply chain needs to evolve, needs to see that how are we able to bring our costs down, how technology is evolving on a daily basis, how is it becoming affordable for the end consumer, how are we able to really see that what is usable for us, what really makes sense, whether it's when I talk about the whole ecosystem, whether it's charging, whether it's the supply chain, whether the ultimate product or the operational aspect. All these are big challenges which need solutions from us today. But all these solutions would not come just for looking at a complete ecosystem solution in one go. We'll have to take requisite steps for the same. Today when we compare diesel, CNG, hybrid, electric, we clearly see that there is a big cost saving in terms of energy in case of electric and partially in case of hybrid. But how are the SRTUs able to buy such kind of buses, ply them on the roads? How is the complete team of drivers, operators who are going to use these buses, how training is going to be imparted to them, that's a big question mark. But more than that, I think even if we get these vehicles on road, the big question lies with the charging technologies. Because the whole ecosystem, they need that kind of support. The government would need to give that kind of long-term vision to the people, as we heard today morning from the Honorable Minister. So if we talk about the cable and plug technology for charging, it needs 16 to 100 kilowatt of charging power. So are we able to give that kind of quality power? Definitely it's a good solution, because it helps the vehicle to be mobile. You can charge carry the charging system with you and with plug and play. But definitely it has its own qualms, because the number of batteries you would like to put on the vehicle would be very high, and that will increase the cost of the vehicle, which in turn has to be borne by the customers, which is in turn paid by the taxpayers. So are we ready for it or not? Similarly, the pantograph solution, which is spreading very well and is a solution of choice in Europe, but the infrastructure needs to be put in place. It's a dedicated corridor which will be there, where multiple different vehicles can be charging with the pantograph solution. But the power requirement is about 450 kilowatt. So are we ready for that? That quality of power at that source level? Because with one system being deployed, it's a one-time investment, and then on an ongoing basis, we can get the benefits. And those benefits can be reaped by multiple application vehicles. Similarly, we talk about induction charging. It needs about 200 kilowatt of charging power, but the technology is evolving. The technology is still not stable. And in this technology, the kind of know-how which people need, as well as the system which needs to be deployed, is very cumbersome. So still there is a lot of time which needs to, a lot of money which needs to be invested in this technology to make it more affordable. But ultimately we need to see that how our perspective as an industry, we are giving a solution which is economically viable. So therefore if we compare diesel, CNG or electric, we see that the running cost, operating cost in electric vehicle is about 1/3 of diesel and about half of CNG or hybrid. So therefore that is the right solution which I feel can be a good solution for a country like India. But we definitely have to see how we can localize such kind of products, how the infrastructure can be provided by the government, a sustainable and scalable methodology can be deployed, new schemes like FAME and the upcoming NEMMP, I think will be testimony to the fact that what is the government looking for in the future. Because with these kind of buses, we see that fuel saving is about 81% more than the diesel bus and about 47% more than the hybrid bus. The Prime Minister has already spoken a lot about the import of the fuel. How are we going to cut down the import of the fuel? Because it's more than 1 lakh crores which can be saved over a period of time, which can be used for multiple applications, developing the right kind of infrastructure, bringing the right kind of companies to invest in India with the Make in India programs. And also supporting the operators with the maintenance cost reduction, as well as the energy cost is definitely going down by more than 60%. But today, more than that, being an environment friendly product, we really need to see that how it is saving the kind of emissions which we have today, whether we talk about 4 lakh liters of diesel for a bus or about 800 tons of CO2 which can be saved with such kind of products. So I think that is a focus which we need to have. If we are looking for a one-off solution that would not give the right perspective, we need to have a holistic approach where the complete ecosystem is set in place with the right steps which we take on an ongoing basis. This is one comparison which I really liked, that how transportation is evolving in India, how people really need to see that on one end you have 60 cars which are having about 1.5 people per vehicle, or 60 bikes having people drive those bikes, or one bus. So we really need to see how public transportation is the choice of the future, as we heard in few of the previous sessions also, and is the right choice, because most of the countries which are developed today, people coming from any side of the society, whether middle class or HNIs or people from the lower side of the society, are always more comfortable using public transport, whether it's a bus or a metro or other applications. Thank you.
Thank you, Mr. Arye. We have the next speaker in Magnus Broback, is the Director, City Mobility from Volvo Bus, Sweden. He is basically an engineering and industrial engineering and management graduate. He has led several projects implementing new technologies, supporting new solutions. Before joining Volvo Buses, he led the development of fleet management services for Volvo Trucks. Currently, he has the position as City Mobility Director at Volvo Buses.
Thank you, Mr. Chairman, and thank you for ASRTU to invite me and to have this opportunity to talk to you about the global experience of electromobility from a Volvo Bus perspective. I'm happy to be here. This is my first visit to Delhi. I've been in telematics, as you said, and at that time I visited Bangalore, but now first time in Delhi. Very nice to be here. Thank you. And also very happy to see the journey that Volvo has done in India over the last 15 years. Selling now to 250 customers, having over 5,000 buses in operation, and more or less with our coaches connecting every Indian city. It's fantastic. Coming from Gothenburg in Sweden, this is a nice journey for Volvo Buses in India. I will talk to you about our global experience of the electromobility, because we believe that addresses a lot of challenges in the future of public transport. I will start with a picture from the royal wedding where Prince Carl married the beautiful Sofia in June in Stockholm. Volvo Buses were asked to provide transportations for all the prominent guests from the church to the dinner. And as you can see on this picture, I think it's a good illustration of what public bus transport should look like. It's dedicated lanes, it's prominent people or middle-class people going in the buses, and actually the people are giving standing ovations to the bus. The bus we used on this one is now in commercial operation. It's our brand new electric hybrid with the possibility to drive approximately 70% of a normal route on electric. Of course, this was a statement by the royal family. They see public transport as a big potential solution to the future. As I said, the electromobility addresses a lot of the current challenges. It is innovation by the possibility to leapfrog to get in to create zero emission zones. It increases the travel experience, the low noise, and also the less vibrations makes the passengers inside the bus as well outside the bus more happy. And don't forget the bus drivers. We have had electric hybrids running in the streets in Gothenburg for 3 years. The bus drivers love it because they are not getting as tired as using a normal bus, and by that enhancing safety in the roads. Sustainability. I would say that's the key for Volvo choosing electromobility as our main path ahead for city applications. Already in 2007, Volvo made a very thorough study of different alternative fuels. We looked at ethanol, methanol, hydrogen, gas in different shapes, and we came to the conclusion at that time that electromobility is the key for city applications. And at that time, we also realized that buses are perfect to drive this development. So Volvo Buses was given the responsibility within the Volvo Group to develop the electromobility path. And 2 years later, in 2009, we introduced our first hybrids, which now have been in operations for over 6 years, and we have sold more than 2,000 hybrids so far. And what we saw in that study as well was that the electric engine is fundamentally more efficient than the combustion engine. And that's why it's a lot more efficient to drive with an electric engine in the city applications. We use the example with the same amount of energy, you can drive a gas bus 1 kilometer and you can drive an electric bus 3 kilometers. So that systemic approach, or that systemic efficiency of the electromobility gave us the path. We revisit this study every year and look at it, and we still believe electromobility is the most efficient for city applications. Next point, financially viable. We see today, if you calculate total costs, including environmental effects and health effects, that in Europe, electromobility is slightly more expensive, but it's getting there and will be soon be more efficient. From a life cycle perspective, including health and emissions and costs related to that. So how do we do it? The previous speaker gave us a lot of examples of how you can do this. The bus you can see in this picture is our brand new electric hybrid. We see that we need a range of electric products in order to cater for different applications. So we have hybrids, we have electric hybrids, and we'll have full electric buses. And if you look on where we're going to use them, you can see that for long haul and coaches and long, probably diesel will be a good alternative also in the future. But the closer you get to the city, the more electrification will be sustainable. Let's go. And as I said in the beginning, Volvo Buses was given the responsibility. That was due to the city applications, but also that buses are perfect for electromobility. The routes are a lot more predictable than other applications, and they operate probably more than 10 hours per day and even more than that. So that makes the use of these resources that it's needed for batteries much more efficient. Compared to a car, for instance, it's used a couple of, perhaps I think the average is 45 minutes per day. So let's use our scarce resources where they make best use, in public transport and in buses. So when, as I said, the hybrid was introduced in 2009, we will state that this is a mature technology today. It has been proven that this gives great effects. Next year, we will start in Europe the production of the electric hybrid that was used in the royal wedding, as you saw in the beginning. And the year after that in Europe, we will also introduce the 12-meter full electric bus. Bi-Arctics or Arctics will come later, probably in Latin American applications, perhaps for BRT, as has been mentioned. And as you can see on this slide, we have a fast charging concept. I won't go into details on that. If you want to discuss that, I'm available, both today and tomorrow. But that's the technology path that we have chosen. How much? The question of costs. As I said in the beginning, when we calculate life cycle costs today in recent quotes in Europe, we can see actually that hybrids is less than diesels. And electric hybrid, as I said, a bit more expensive, but that is 2015. When we look at the projections ahead, the former speaker was also touching on that, the price development and the cost development of these different, we see that for sure in the next coming years, this would be a very competitive offer from a financial perspective as well. The key to this is to have high usage, because then you make the most out of this, and as I said, city operations as well. Our global experience, we have had hybrids. It was mentioned before I think it was over 400 actually, hybrids in Bogota that is operating. Curitiba and Mexico City are other major hybrid cities who has a lot of hybrids in traffic. So that, as I said before, this is a mature technology. We think it's perfect. Regarding the next step, the electric hybrids, you have seen the Stockholm bus before. Hamburg was started in December last year. They will run on a specific line with this concept. And Gothenburg was actually started a couple of months ago only. And the Gothenburg project does also include other aspects. Someone mentioned Wi-Fi on the bus. In this project, we also have Wi-Fi on the bus stations, in order for the young people to never be disconnected. I would say thank you at this stage. As I said, 2,141 hybrids sold so far. That gives us confidence to continue the journey of electromobility. And thank you for letting me speak here.
Thank you, Mr. Broback. We have the last speaker on the panel today. We have Mr. Urban Loeffenberg. He's a Master in Science from the Royal Institute of Technology, Department of Material Science and Engineering in Stockholm. He started his career with project management within the chemical industry, and over the last 15 years he's worked with product and business development for several European companies. Currently holds the position as Product Manager, Sustainable Solutions at Scania. Over to you.
Thank you. Good evening, ladies and gentlemen. It's always difficult to be the last speaker, especially when the program is delayed, but I hope you should appreciate this presentation about biofuels. Biofuels in public transport here and now. I'm also glad that the speakers earlier today have already covered a lot of what I have planned to talk about in the beginning. So I think I can keep the time to 10-15 minutes. But I will start just to mention very, very short trends in the world cities today, and something about Scania's view on solutions for sustainable transport. And then going to the main topic for this presentation, ethanol and biomethane as vehicle fuels. The population in the countries globally increase. And the 20 most populated countries, 2010, you see here. And China was then the biggest populated country, and number 2, India. And the forecast for 2050, then it has changed. Then India will be the most populated country. Then India has increased with 5 million people, and China has reduced with 50 million. So increasing cities leads to a city-dominated world. More and more people move to the cities, and today more than half of the global population live in cities, about 53%. And it will increase to 60% 2030. So the cities will be dominated, both in economically and in transport. And the urban mobility, both for people and goods, will triple between the period of 2010 and 2050. And sustainable city mobility for people and goods, the key factor is to stay attractive and to be competitive, and that's also, for example, is for Scania. Solution for sustainable transport. Of course, there is not only one solution. There is no silver bullet. There are a lot of solutions that we must combine. But we can divide it mainly in three different groups. We must have smarter transport for people and goods. We must save energy and also replace fossil energy with renewable energy. Smarter transport we have heard a lot about today, so I will not go into that, but I will mention one thing. The last two lines, the cost for the BRT system and the metro system. The BRT system in Bogota, the capacity is 45,000 passengers per hour, and the cost to build that system was $5 million per kilometer. Compared to the metro system in Mexico City, the capacity is 39,000 passengers per hour, but the cost is more than 8 times more per kilometer to build. The second part in the sustainable transport is to save energy. And that also we have heard a lot of things today. One thing which is very, very important is the driver. The driver, to train the driver, can easily reduce the fuel consumption with at least 10%. In average, for the truck drivers that we have educated in what we call Ecolution by Scania, we reach about 15% fuel reduction in average. So the driver is very, very important when it comes to save energy and save fuel. Scania also work on hybrid. We launched our first hybrid city bus last year, and this will continue now for Euro 6, and we have hybrids also, not only for diesel, we have it also for biodiesel, and other renewable fuels also will follow with that. We're also doing tests with inductive power and with the pantograph. And today we're already running trolley buses in Sao Paulo. But I will say one thing regarding electricity. To be cost efficient and commercially viable, electrification has to be a part of a large-scale industrial modular system. It has to be planned, it has to be built in a large scale. When it comes to electricity, clean electricity, clean sustainable energy is usually associated with electricity. But almost 80% of all electricity produced in the world today is made by fossil fuels. And in India, about 70% is produced by fossil fuels, and most of it is from coal. So that is something that we have to think about. Markets and countries that have a lot of renewable electricity, then it's good to use that. But when you use a lot of fossils, then the electricity, of course, you get cleaner cities, but the emissions will go somewhere else. Third part, replace fossil energy with renewable energy. There is a rapid growth in biofuels today in the world. From year 2000 to 2010, the renewable fuels quadrupled in volume. And it's estimated that from 2010 to 2050, it will be almost a growth in 10 times. And still, biomethane, biogas or bio-CNG, as they say here in India, ethanol and biodiesel are still the three main biofuels, even 2050. Biofuels are meeting all city needs. Yes, we clean up the air, save lives in urban areas. These two pictures is from China. It creates local domestic jobs. It turns waste to fuel. to clean local fuel, and it replaced costly diesel and oil import. Scania has, since almost 20 years now, focusing on developing vehicles for biofuels. And today we have buses and trucks for the three major commercial renewable fuels that we have in the market: ethanol, biodiesel, and biogas, and then also, of course, CNG, natural gas. Bioethanol and biogas is the most has the most CO2 reduction capacity today. I should say more than 90% if it's a good production. And also biofuels meeting this, all the city needs in respect of transportation capacity. Using bio-CNG in the cities, in the inner city and in the suburban area, and then in the regional area and outside the cities using ethanol. When it comes to the fuels, to the biofuels, I will talk a little bit about that for the rest of my presentation. Bioethanol is produced from organic materials, and it's a very well defined molecule. Diesel, petrol has long chain of coal. This is just a well-defined molecule. It is clean fuel, and it's produced by fermenting sugar. And you see here some examples that you can produce the fuel from. Waste, all kind of organic waste that contains sugar and starch. Sugar cane, sugar beet, cellulose, corn and wheat. Lot of material that in different markets there is a surplus of, and waste. Also biogas is produced from organic materials, but not from fermentation, but from anaerobic digestion, which means that the process continues without adding or supplying oxygen. Methane is also a very clean say gas. It's a defined molecule. And the methane from biogas and natural gas is of course the same methane molecule, but the natural gas comes from fossil sources. How do we produce the fuels then? As I said, we start with organic waste, organic material. The biogas, we use anaerobic digestion to produce the methane. Then we get the first step, raw gas, containing 50 to 65% of methane. This has to be upgraded for using as a fuel in a vehicle. Take away carbon dioxide and hydrosulfide. And then we get the biomethane or bio-CNG at the content of about 97%. The ethanol, we can use the same material, fermentation process, and then distillation, take away the water. Then we get the 95% ethanol about. The ethanol we use for the bus, you have seen the green bus outside here. The ethanol, the Scania ethanol bus, use this ethanol, 95% of ethanol with 5% water. And then also some fuel components in the fuel. And the fuel is called ED95. It's a global name of this fuel. And in Sweden we have been running this for 25 years, and Scania have exported biogas buses to cities in more than 10 countries now. The ethanol engine is a compression ignition engine. It's not the Otto or petrol engine with spark plugs. It's a diesel functioning engine. And why a diesel engine? mainly because the high energy efficiency. And with ethanol, we also reached almost the same energy efficiency using the diesel technology. And the composition of ethanol is 96%, and the rest is fuel components. And the infrastructure is the same as for diesel and petrol. So there's not any new expensive infrastructure that has to be built. We can use the same type of infrastructure. There are some difference in the properties, cetane number, biofuel content, and also the energy content are different. Otherwise, it's a liquid fuel. Ethanol E95 should be handled as petrol. That's the difference compared to diesel. And there is today a very well-defined specification of the ethanol that should be used. The E95 fuel is also a certification fuel for the European market, so we can certify our engines on this fuel. And there is also Swedish standard, and I know that in South Africa they are working with a standard on the E95, and also here in India this work has been started. The gas engine is an auto engine, and this engine is for Euro 6. I forgot to say the ethanol engine is for Euro 5 so far. This gas engine is Euro 6 with almost the same energy efficiency as Euro 6 diesel, which is the best engine, gas engine so far in the market. Also the torque and power is almost the same as diesel, a little higher in the RPM over 1300. To mix biogas and natural gas is of course possible if you have a grid with gas in the city. But the standards has to be met for both fuel before you blend it. And the gas fuel can be supplied in compression or in liquid form. This is also a very important thing. I mean, in Europe we have made a journey from 92 where we entered into Euro 1, and now we are in Euro 6. You see the little white square in the close to Origo. And this journey is that we have reduced the particulates with 98 to 94%. Introducing biogas in India and ethanol in India for the city buses means that you can do this leapfrog from Euro 3, Euro 4 directly to Euro 6. As I said, the biomethane engine is Euro 6, and today's ethanol engine is Euro 5. But the Euro 6 ethanol engine we will launch during next year. So conclusion, growing cities will push for clean and efficient transport development. Clean, sustainable biofuels in public transport are here and now. We don't need to wait. We can use what we have and then develop the better technology, but we should use what we have today. Easy and cost-efficient technical solutions and infrastructure. And as I said, ethanol is equal to diesel and petrol in respect of infrastructure. Biofuels meeting all city needs, leapfrog to Euro 5, Euro 6. And then also biofuels has a very positive effect on the economy and social factors, especially turning waste to clean fuel, I will point out that is a big challenge and a big possibility. Thank you very much.
Thank you. Well, I just take a few minutes to I just take a few minutes to share some of my views and also wrap up this session. We have had varied speakers, who have been talking about the various alternate fuels on which they have been working, and we have also had speakers talking about the issues the society is facing today with the usage of the alternate fuels. But one thing is very clear is that the very search for the alternate fuel has started primarily for two reasons. One is we need the energy security, and then obviously the second one is the environmental reason. What do we mean by energy security? It means different things for different countries, but at the global level what we really need to understand is most of the energy sources that we have today are from the fossil fuels, whether it is crude, whether it is natural gas, or whether it is coal. Ultimately, whatever may be the form of energy that we use, or whatever may be the form of fuel that we use, it all comes from this kind of fossil fuel, which are exhaustible in nature. You cannot replace them. It's going to get over sometime in future, maybe 30 years, 50 years, 100 years, we don't know. Even the kind of fossil fuels that are there which have not been tapped, or the ones that we have started tapping in the recent past, we see that the technologies are yet to develop, they are expensive, and they are dirty technologies. So if you are really looking at energy security and also trying to achieve the environment-friendly kind of fuels in future, then I think we really need to think differently. So then we have to really look at new sources of fuels which are environment-friendly, which are renewable, which are sustainable, and also affordable. So how do we really achieve all this is the big challenge. And then one of the things that appears very promising before us is the biofuel, because it is environment friendly kind of a fuel, renewable in nature, possibly it could become affordable in future. But then the way we have driven the biofuel industry at the world, at the global level, we have seen that it also has generated quite a few debates at this point of time. It has become controversial. One of the speakers did talk about the energy versus food security issues. When we talk about energy versus food security issue for a country like India, the debate has to be something totally different. We can't be debating energy versus food security. One of the speakers said that India is the second most populous country, and we are soon going to be the most populous country on earth. And we are one of the fastest growing economy, and we need the fuel to sustain the growth. And we also need to feed the people. So the debate here is, how do we achieve food security and energy security? Do we have a roadmap for it? Do we have a clear strategy for achieving food security as well as fuel security for this country. And that is what the government is currently looking at. There are several ways in which this can be achieved. I just want to share one or two points which would possibly help you put on your thinking hats. So, for example, ethanol. We talk about ethanol being blended with petrol, and our current consumption of gasoline or petrol is about 20 million tons. And we are talking about not using the land for growing food crops for growing ethanol. Yes, we need not have to. Then where do we get our ethanol from? We are an agrarian society. We have 52% of our land in this country, which sums up to something like 190 million hectares of land which is arable. And we are growing different types of food crops already on this land. And we are generating something like 500 to 600 million tons of agri-residue, and only about 45 to 50% of it is being consumed for various different applications. Close to something like 300 to 320 million tons of agri-residue is being burnt on the field, which is also contributing to the environment problems that we have today. We have the technology today, the second generation biofuel and bioethanol technology, the lignocellulosic conversion. And if you can adopt the technology, and this technology is there today, and if you can even convert 50% of the kind of biomass that is being burnt out in the field, we are talking about something like 40 million tons of ethanol being produced, which can replace 100% of the gasoline that we are consuming today, and we have more to export or available for various other applications. And then we consume something like 70 million tons of diesel per annum. And how do we replace this diesel? You know, there may be probably a small part of the diesel can be blended with ethanol, but we require biodiesel in very large quantities. I did mention that we have something like 190 million hectares of land, out of which only 40 million hectares of land has been irrigated. We have 150 million hectares of land in this country where we grow only one crop during monsoon, and rest of the time, almost for about 7 to 8 months in a year, it has been left barren. So we have highly productive land which have been left barren, rendered unproductive. And can we not come up with kind of a plan where we grow tree-based oilseeds and also short gestation crops which can give you enough feedstock for our biodiesel production? Out of the 140 million hectares of land, even if we can convert 50% of the land to use the land for growing the kind of feedstock that is required for the biodiesel program, and even at a very low productivity of 1 ton of oil per hectare, we are talking about 70 million tons of biodiesel that can be produced in this country. So, how do we really achieve this? For this, we need to have a policy in place. I think the biofuel policy the country has, which we adopted in 2009, is one of the most progressive policies that we have adopted in this country. We have a very clear roadmap being drawn now. We have heard the minister in the morning. We issued notification for 5% ethanol blends in 2003, for 10% in 5 states in 2008. When the new government took charge, they reviewed the situation, and we found that at pan-India basis the blending was only at 1.7%. The few steps that were initiated in the last few months, it has taken the blending levels to about 3.1%, and before end of this year, on a pan-India level, we will have 5% ethanol blending, and by end of next year, we would be getting very close to 10% blending of gasoline with ethanol. So we have the kind of resources, we have the technologies. All that is really required at this point of time is the political will, which is being demonstrated today by the present government. And the Honorable Prime Minister of the country has also set a target for the Ministry of Petroleum and all other concerned ministries, saying that by 2022, we have to bring down the import of fossil fuel by 10% of the present consumption levels. That means, even taking into consideration the kind of demand that is going to come in the next 7 years, we are looking at something like, a 15 to 17% reduction in the import of fossil fuels. So there is a very clear roadmap. There is a policy framework. Mandates will be put in place. Roadmap is there. Is being created now. Trying to bring in all stakeholders. To start with, we have various ministries which has to get involved in this program. If you really look at the entire value chain, starting from the feedstock production, where the ministries like the Agriculture Ministry, the Ministry of Rural Development, Panchayat Raj, Ministry of Environment and Forest, they all have been engaged in discussions as to how they can get involved in the feedstock production. And then we need to put a lot of operational mechanism in place for the aggregation of the biomass, processing of the biomass, the blending with the petroleum products, and also using the biofuels and the various byproducts for meeting various different types of rural energy. So it's a fact that the world has to move from the present set of fuels that we have been using to a new order of fuels in future, and the country needs to do a lot more in this regard. And I think we have taken the first few steps in this direction. So I would like to stop at this, and probably we will take a few minutes for any question answer sessions. Sorry? Okay, so that makes my job easier too. As we are coming to the end of the day, the organizers suggest that any questions, we could do it over a cup of tea or even tomorrow with the speakers who are going to be here today and tomorrow. So with that, I thank all the panelists and also the organizers for having provided me an opportunity to chair this session. Thank you.
Thank you, Chair, and thank you to all our expert panel here for sharing their expertise with us and for the deliberations on the relevant theme. Before we conclude the session and conclude the day, may I please request Session Chair in his capacity as Chair to kindly present the mementos to our speakers present on the dais. May I request him to present a memento to Mr. Jeffrey Hewitt, to Mr. Nishant Arya, and I now request him to present a memento to Mr. Magnus Probak. And last but not least, I request him to present a memento to Mr. Urban Loeffenberg. And ladies and gentlemen, on behalf of ASRTU, may I please request Shri Anand Rao to kindly present a memento to our session chair, Mr. Y.B. Ramakrishna. And before we conclude the session, just a few important announcements. I'd like to request people, ex-team members in the audience, to kindly take a tour of the exhibition tomorrow. We start our first session tomorrow morning at 10 a.m. We have the ASR2 Productivity Awards, which will be followed by the important panel discussions. And just like today, we'll also have the webcast tomorrow. So with this, we conclude day one of the conference. Drive safe and have a great evening, and see you tomorrow morning. Namaskar.